Okay, cool. Now, what number do we want to use now? X equals what? 2? 1 times 2 is 2. Add it. Negative 5. Multiply. Negative 10. Add it. 6. Multiply. 12. Add it. 0. Then we're left with 1x squared minus 5x plus 6 multiplied to negative 2 and negative 3. So I get x equals 2, comma 3. So when I go to get my answer, what is it going to be? X equals negative 2, 3, 2, what? Talked about this yesterday. Starts with M, rhymes with multiplicity.
Multiplicity.
There you are. Multiplicity what? 2, because there's 2 of them. If you don't write that, we don't know that there's 2 of them. Right?
Is it plus or minus 2?
Oh, yeah. Wait, is the whole thing multiplicity 2 or just the last 2?
How many have 2? Just the 2.
So wait, so how do you know it's the 2 is multiplicity 2?
Because there's 2 2s.
Oh, so you don't just write 2 twice?
No.
So you know it's multiplicity 2 because, so that means it's like parabola that goes on 2.
Yeah. Just type this one into your calculator. That's a point for today. Type that one in. Yep.
So you don't have to write them anymore as the factors, like x.
Not if it doesn't say factor. So if it says solve, you want x equals. If it says factor, you want the factors. You could write the factors above and then put solve, but you wouldn't box the factors, right? You only box the solving. So everyone type it into your calculator. Go. Every single one of you. Type it in. Still recording.
There's 1 to 2, but then the parabola one.
So, if you zoom 6 it, this is what you have sitting there, correct? Okay, guys, we talked about this yesterday. This is the constant. This doesn't have any brackets, we agree? We're going to talk about this today as well. Do you see how this doesn't have any brackets? Okay, what is negative 24?
It's y-intercept.
Why would it be the y-intercept?
It's the last number.
But why is it the y-intercept by solving? When you hear y-intercept, you should think x equals 0. Let's put zeros in for x. If I find f of 0, or this one would be p of 0, sorry. That means I'm filling 0 for all my x's, right? In that bracket. So I get 0, 4, minus 5 times 0 cubed, plus 2 times 0 squared, plus 20 times 0, minus 24. Anything times 0 goes away. So I have p of 0 equals negative 24. Now this is just function notation for what coordinate? What's the coordinate? The coordinate is an xy. 0 is my x because it's in the bracket. Negative 24. So it is my y-intercept. We agree?
Yeah.
So that's why that last number is your y-intercept when you have no brackets. Because when I plug 0 in for all those x's, those terms will just cancel off. We agree?
Yeah.
So when I go to my calculator and I have it negative 10, 10, negative 10, 10, I know that this graph has to go lower because there's a y-intercept of negative 24. So that will lead me to know that it needs to be at least lower than that. So people will say, oh, I can just make my y minimum negative 24 then. Cool, let's press it. But it still goes lower because that's my y-intercept, correct? That's not my minimum. So I'm going to make it be negative 35. I don't know, I'm just random. Oh, so close. negative 40. I'm going to make my scale be 5. So there's my graph. Does it make sense? So we said, what were our x-intercepts? Negative 2, 3, and 2 multiplicity 2. So at negative 2 it went straight through. At 2 it went up and bounced back down. So that makes sense because there's 2 there. So it's going to be a point of tangency, right? And then 1 goes straight through again at 3. So the graph confirms what we found, correct? The graph confirms what we found. All right. We're going to go to 3. So for 3, what can I use? X equals what? Negative 1. So I have 2, negative 14, 25, and negative 4, because I checked if I could count down. 3, 2, 1, 0. If I can't count down, I need a placeholder. We agree?
Yes.
Okay, so I drop the 2. 2 times negative 1 is negative 2. Add it, negative 16. Multiply 16. Something is wrong. Negative 1 is not going to work. What do I have to use? X equals, ooh, that's an eraser.
Oh, that's number 3.
Yeah. X equals
4.
4. So I drop a 2. 4 times 2, 8. Add it, negative 6. 4 times negative 6 is negative 24. Add it, 1. 4 times 1 is 4. Add it, 0. That one works. So now I'm left with 2x squared minus 6x plus 1. And I say, what multiplies give me 2 and adds to give me negative 6. Is there anything? No. So, guys, reminding, if this said factor, does it say factor? No. But if it did say factor, my answer would be x minus 4, 2x squared minus 6x plus 1. Right? That would be my answer. Does it say factor? No. This is just a little caveat off to the side to remind myself. If it said factor, that would be it. Right? Because I can't factor that one. So I would have a linear factor and a, which is also known as a, we did this last year for 2 units, quadratic factor, right? Linear, quadratic. Okay, so, but it doesn't say factor, it says solve, so I have to keep going. So this is my A, this is my B, this is my C, it's set equal to 0. Now look here, guys, what does this formula actually have, which no one shows? What is this little variable that's in front of the formula? X equals. Now, if it's x's, I use x equals. If it's like m squared or p squared or whatever, then I would use p's, right? It's not always an x, it's whatever the variable is. In this case, it is an x, so I have to go x equals. If you're someone who never does that, you have to. You have to go whatever the variable is equals, right? Because you're telling me what x equals. And then it's negative b, so it's negative a negative 6 plus or minus the square root of b squared, so negative 6 squared, minus 4 times a, which is 2, times c, which is 1, all over 2 times a, which is 2. So I'm just inverting my numbers. And so I get x equals negative a negative 6 actually becomes a plus 6, plus or minus, and then I do what's underneath here. So I get 36 minus 8, which is what? 36 minus 8, which is?
28.
28 over 4. Now, I'm going to reduce 28 off to the side instead of doing it in there. So root 28. Remember when we reduce radicals? We have to actually break it down into a perfect square. So it's like 4 or 9 or 16 or 25 or whatever. All right, and do any of those, does 28 break down into it?
4 and 7.
4 and 7. And the reason why we need a perfect square is because if I just do 1 and 28, cool, it just stays, right? There's nothing I can do. But I can take a 4 out. The 4 comes out and it becomes a what?
2.
A 2. And then it can come out. Can the 7 come out?
No.
No. So unless it's a perfect square, it can't come out, right? You do a whole entire day's lesson on this in grade 10. And so you get 2 root 7. And the reason why that is, why can root 4 become 2? Well, root 4 is just the same as root 2 times 2, right? And as long as you have 2 of something, you can write it as just 1 of it if it's underneath it. So that's why it works. Like root 9 would be 3 times 3, so you can take 2 for 1 out, right? If it's a cubic, you'd have to take 3 for 1 out. So that's why it has to be a cubic number. So now I have x equals 6 plus or minus 2 root 7 over 4. Now I sometimes get this one, don't do this, and people will say, okay, 2 and 3. Can I do that?
No.
No, it's bad. It has to be a 3 for 1 special. So you have to be able to take it out of all of the numbers or you can't take it out. Now why is that? We always cancel it off, but why? Why can we do that?
Every term can be.
Because you're actually taking a GCF of that out and just crossing it off. This is what you're doing when you're canceling them. So I want you to understand why instead of just canceling them. So for this top one, I'm just explaining why. I don't expect you to write it this way. I'm just explaining why. I can take a 2 out of the top, and I would be left with 3 plus or minus 1 root 7. And then the bottom I could break into 2 times 2, right? Do we agree? And then when these cancel off, they just become 1s, correct? And so then that's why you're left with 3 plus or minus root 7 over 2. Because you're literally taking a GCF out of all of them and then canceling it off, right? So instead of showing it that way, you can go, okay, I can take a 2 out of here, I get a 3. 2 out of here, I get a 1. 2 out of here, I get a 2. But the reason why that works is because you're GCFing a 2 out of everything, right? And so you get x equals 3 plus or minus root 7 all over 2. Comma what? 4. Don't forget your other 0. See how easy it is to forget that other one that's on the synthetic division symbol? Because you've just done so much math and you're proud of yourself and it reduced and it worked out. Now, can we check and see if we're right? Yes. We can type this into our calculator and find our x-intercepts. We'll get 4 and then we turn these into decimals and check them, right? We practiced that before. So it would be the same thing. Okay? Remainder theorem, guys, is actually just function notation. Shh. Okay. Input x. Love when it does that. Input x. Output y. And we've already talked about this in short form before. Remainder theorem, input x, output y. So, okay. Say I give you f of x equals x squared minus 2x minus 3. We're just doing grade 10 math here. If I give you f of 2, what are you going to do? Replace the x's with 2. So we're going to go 2 squared minus 2 times 2 minus 3, which gets me negative 3. What did I just find?
Why?
Even more so, what did I just find? I found a coordinate on this graph. It's at 2 and negative 3. Really, that's whenever I do function notation and I do an input and get an output, I'm literally just finding a coordinate on that graph, right? Okay. Now, what if I ask you for this? F of 3. So I'm going to do an input and an output, right? So I'm going to go 3 squared minus 2 times 3 minus 3. And then I get f of 3 equals 9 minus 9, which is?
0.
So what did I just get on this graph now? I got a coordinate again, 3, 0. But that's a special coordinate. What is it? It's an x-intercept.
That's 0.
Because my y is 0. Could I work it back to a factor now? Oh, come on, Lord. Could I work it back to a factor if I know it's an x-intercept? What would the factor be? So this is indirectly telling me x minus 3 is a factor. Because we move it back, right? We would have x equals 3, and we subtract it over and get it equal to 0, right? We've done that over and over and over. Still grade 10. We haven't done anything crazy, right? Still grade 10. Okay. Now, the remainder theorem states that when you substitute in a y, sorry, an x, your output y is the remainder. So if I did synthetic division, that boxed number is the remainder. We agree?
Yes.
So if all they wanted was the remainder, I wouldn't have to do synthetic division. I could just plug in an x and get out a y. And that would be my remainder, right? So if I gave you p of x equals x cubed minus 3x squared plus 6x minus 4, and I tell you it's divided by x plus 1, determine the remainder. I could do synthetic division, or I could just do what? Divide, yeah. Go x equals -1 and insert that in, right? So x plus 1 is the factor, x plus 1 equals 0, so x just equals -1, and I plug that in and see what I get. So I could go p of -1 equals -1 cubed minus 3 times -1 squared plus 6 times -1 minus 4. So I could get p of -1 equals -1 cubed is -1. -1 squared is +1 times 3 is -3. 6 times -1 is -6 minus 4. And I get p of -1 equals -14. So this is my remainder, technically. But what did I also just find? A coordinate on the graph of p of x. I did find a coordinate. That's what I did find, correct? I found a coordinate as well. It's at -1 and -14. Now, proving that I'm not a liar.
What's the divided by x plus 1? You had that as something and it didn't really affect the equation at all.
You have to find your x.
You have to find the x from it. That's how I got the -1 to fill in. It's dividing by the factor x plus 1.
Wouldn't that put the entire thing over x plus 1?
Yeah, but we don't have to do it long division. I'm showing that we can just do remainder theorem to get a remainder. And now I'm going to show you that we could do synthetic division, we'll get the same remainder. So if we do synthetic division, we would use 1, -3, 6, -4, and we would use x equals -1, because whatever we divide by, we use the root of it, not the factor. Okay? When you're dividing by x plus 1, we've been doing that the whole time. It's just synthetic division. Yeah. We just aren't doing long division. We're taking, because remember when we take that x out, we were left with x squared down here? So we've been doing it the whole time. So we drop the 1. We get -1 times 1 is -1. Add it, -4. -1 times -4 is 4. Add it is 10. -1 times -10, or positive 10 is -10. Add it is -14. Here's my remainder. So they are the same. Are we paying attention so I don't lose you? Doing synthetic division gets you the same remainder, doesn't it? So, where is this even helpful? Well, it's helpful if I give you a polynomial that's missing a letter. It's missing a coefficient that you have to find. So if I just ask you for the remainder, you could do synthetic division every single time and just get it, correct? Or you could plug it in and get it quickly. If I ask you to factor or solve, can we use remainder theorem to find that? No, it's called remainder theorem because it just gives you the remainder. But where is remainder theorem needed? A necessity. Well, helpful. You could do it in synthetic division still anyways, it just makes it harder. Well, it's a necessity or helpful when I give you this. Determine the value of k. If x minus 2 is a factor of x squared minus x plus k. Now, what we need to do is we need to read into is a factor here. If I see is a factor, I immediately underline it and then put something. Now, whenever something has been a factor and we use it in synthetic division, what was the remainder? 0. So if something is a factor, the remainder is 0. Remember when we factored, that's what we did. When we factored, we put in a factor. We take our factor, we turn it into an x-intercept, and we get the remainder is 0 every single time because we were using an x-intercept technically, correct? So if something is a factor, we indirectly know the remainder. So if I see is a factor, I go remainder is 0. So what the heck does that mean? That means my input comes from here. My input is x equals what? 2. My output is y equals what? 0. So let's input it. So say we have p of x equals x squared minus x plus k. I'm filling what in for all the x's? 2. What goes over here? What is p of x? Just a fancy way of saying. It's just your y, which is 0. So k would equal -2. Can we always check this? put a negative 2 back in for k, so we can get x squared minus x minus 2, right? And we could plug in the 2 and see if you get to 0. You can always double check. Okay. I'm going to give you 2 more examples instead of giving you them for homework. Okay. B. P of x equals x cubed plus 4x squared plus x plus k, where x plus 2 is a factor of P of x. Then C, x squared plus kx minus 16, oops, P of x equals, where x minus 2 is a factor of P of x.
Is that 2x?
Where?
Is that 2x? Or
This
x
is
squared?
px equals x squared. I just inserted the P of x after the factor.